Everyone. I am your chair for the Waste Not, Want Not, Creating Renewable and Opportunities for the Next Decade session. I would like to introduce to you the discussants and then the speakers. So let me just bear with me for a few minutes. Firstly, Dr. Chadee. So Dr. Chadee is one of our discussants. She's actually gonna leave us partway through the session, but for now, and then we're gonna have Dr. Felix replace Dr. Chadee halfway through the session. But so let me say, Dr. Chadee is an accomplished renewable energy scholar in the UWI network. It's a pleasure to work with her. Her research interests include wind energy, wind resource assessment, wind farm development, Trinidad and Tobago. She's studied environmental physics, climatology. She solved problems using methods from meteorology, air pollution, transport. And she's a proud graduate of the University of West Indies, St. Augustine campus, where she studied at the environmental physics lab. She's worked at UWI since 2013, and she's now the coordinator of the MSc in Renewable Energy Technology program, and is also a lecturer in the physics department at UWI St. Augustine. And just to I'll introduce Dr. Felix now, since she'll take over halfway, and I don't want to stop to do new introductions. But Dr. Felix is a graduate of the University of West Indies St. Augustine campus with a Bachelor of Science degree in physics, a postgraduate diploma in coastal zone processes, and a doctorate in civil engineering. She's currently a full-time lecturer in the Faculty of Engineering in the Civil and Environmental Engineering Department, and her research interests include fluid mechanics. She's an accomplished computational fluid dynamics modeler and also works in coastal oil spill numerical modeling, and has written extensively on the energy transition from oil and gas into renewable energy. So these are our discussants. And now let's talk about our presenters, which I guess we're here for this ONE-UWI Postgraduate Student Conference, and we're very proud to introduce our speakers. Our first speaker will be Lenika Roden, and she's a natural scientist and project management professional with over 7 years experience in the fields of science, energy, and education and training. She holds extensive experience in strengthening global climate advocacy campaigns and convening capacity building training for nature-based solutions in research, policy, and management. And she's studying at the UWI Mona campus. After Lenika, Kian Mason will present. And she's at UWI Cave Hill campus. And in fact, you know what? I'll do it this way because we have Xsitaaz for half, and then we're going to have Portia discuss for half. I'll actually mix it in. And so I'll focus on Lenika now, and we'll get to Kian and Shanice, Dudley, and Shamika later. But let's focus on Lenika. So I'll tell you, Lenika's topic today is the usage of sargassum-derived compounds in phase change materials for thermal energy storage. This is an important area, and with my experience with working with sargassum, I'm excited to see the presentation from Lenika. So let's go to Lenika's presentation now.
Hi, everyone. Hi, thank you. So I will share my screen. All right, so I'm Lenika Roden, and I am an MPhil candidate at the University of the West Indies. I've actually been studying sargassum for a while. Was recently approved for my, will be doing my upgrade soon, so that's so long. I essentially look at the different uses and applications of sargassum. And for this research in particular, I look at the use of sargassum-derived compounds in phase change materials for thermal energy storage. So we're going to go through this presentation, 5-point presentation in 20 slides. So we look at background, problem, literature review. We'll look at an overview of the experiment and of course highlight key findings. So The sargassum bloom crisis, it's a big issue for a lot of Caribbean countries because it's an expensive problem. You know, they spend millions of dollars trying to remove sargassum. It has cost countries in terms of tourism industries, fishing. A lot of fisher folk has complained about the sargassum being entangled in their nets. And so we have that as a main problem. The second thing is that there's a pressing need for eco-friendly, high-efficient alternatives to current PCMs. And I'm going to dive into what exactly PCMs are because I know some of us might not be so familiar. So this is
Lenika,
a picture.
sorry, Lenika, I just want to interrupt because we're seeing it in presenter mode. We're not seeing the slides
Oh,
like a presentation. So I'm not sure if
okay,
you,
thank you for that. Let
yeah,
me
you
just
may not have been
reshare.
aware of which slide we're seeing. So we were just seeing the
Okay, I'll
first slide.
reshare using full screen. I think that should solve the problem. You'll be able to
Okay.
see all the slides.
Yep, better now. Good.
Yeah, so there's
All right, so I'll
sargassum.
restart your timer now.
Thank
Okay.
you so much. I appreciate that.
Okay.
So this picture shows the sargassum bloom crisis, and as you can see, it's literally a mass accumulation of sargassum blooms on the coastline. So if it is that, well, let me backtrack a little bit. Energy is very important for us in our daily lives. It's literally what you're using to power your devices right now, right? And for those of us who don't have our devices plugged in because our laptop battery is that good, then it means that you're relying on energy storage. And so that's exactly one of the key roles of phase change materials. So they're good because they can release stored energy, they have temperature regulatory properties, and they're efficient in energy storage. So PCMs have been used in different ways around the household and in different industries, air conditioning units. In fact, in renewable energy, we use it for our solar panels in order to improve its energy storage capacity and capability. We have heat pumps that phase change materials are used in, passive cooling systems, heat recovery, and free cooling systems. So what exactly is the problem? So yes, sargassum is a problem, but then again, there's a Paris Agreement and the nationally determined contributions that quite a lot of countries around the world have signed on to and have said that, hey, we're going to reduce our greenhouse gas emissions, we're going to try to reduce our reliance on petroleum-based products. With the promulgation of the Global Plastics Treaty that further now states or requires countries to look at ways that, or industries too, to look at ways that they can incorporate more eco-friendly materials and alternatives to the existing plastic-based, petroleum-based materials that they would have been using, depending on what that application is. So for PCMs in particular, they rely heavily on synthetic and non-renewable resources that lack sustainability and environmental compatibility. And so essentially, PCMs are to drive the whole renewable energy transition for countries. Energy storage is something that would need to be ramped up. And currently, energy storage materials are unsustainable in terms of the minerals that are being mined and the use of the synthetic PCMs to boost up their efficiency at energy storage. And so PCMs are without a doubt crucial for enhancing the capacity of energy storage, especially for solar systems, because they effectively capture thermal energies and improve the utilization of solar resources. And research by Simonson in 2023 would have found that sargassum compounds, in terms of their incorporation in phase change materials for thermal energy storage, has been one of the most successful in realizing increased sustainability profiles in energy management. And there's actually a research that was done by Argon Valijo in 2023 again, and it demonstrates that incorporating sargassum compounds into polypropylene composites significantly enhance their thermal stability and mechanical properties. So in terms of the experiment that was conducted, so sargassum was collected off the coast and dried. Sargassum underwent steam distillation and solvent extraction where hydrosol and oil were extracted. Solvent extraction would have involved using hexane and DCM to isolate the essential oils from dried sargassum. And we use GCMS, which is gas chromatography analysis, to then identify and quantify the chemical constituents that make sargassum a good candidate for PCMs. And so this is the setup for our steam distillation process, and this is the oil that was extracted after 1 hour of steam in the sargassum. So I want us to focus on these two main compounds, pentacosane and octadecane. So pentacosane has a high melting point. It has a significant latent heat capacity, and it's stable across multiple phase transitions. Octadecane has a lower melting point than pentacosane, but it's still pretty high in terms of industrially, and it absorbs and releases heat effectively during phase transitions. Now, these properties make sargassum pretty very efficient at storing energy and releasing energy, which is what you need in phase change materials. In the experiment, again, I want you to focus your attention on the pentacosane and the octadecane in terms of their retention times and era percentages. So the retention time, it speaks to the time taken for a compound to travel through the chromatographic column. Its importance is that it shows if the compound is consistent and stable. And for the era percentage, it speaks to the proportion of the compound or the dominance of the compound. So the fact that we're seeing pentacosane as having a very high era percentage and a very high retention rate, and for octadecane, while it has a lower era percentage, its retention time is still pretty high. And when we look at the quality percentages, which speaks to the compound matching back to its reference compound, again, it gives us a level of confidence that pentacosane is indeed present in sargassum at very high levels of accuracy, and so is octadecane, 98% and 96%. And so in terms of thermal stability and phase transition consistency, sargassum holds promise as a bio-based material for enhancing phase change materials. Its unique porous structure and chemical composition, as you've seen with those two hydrocarbons being present, it positions sargassum as one of the leading materials to be considered as a renewable bioalternative to the conventional materials used in PCMs. So we saw other compounds on the charts, and they all had pretty high scores as well. They too have properties that cater to sargassum being able to deliver and perform as a phase change material. So this table summarizes that. So for example, we would have seen the tetracosane, which has a high melting point and a very stable structure as well. We would have seen the heptadecane, which has a moderate latent heat capacity, but has very stable thermal